All right, calculus fans, we're doing some definite integrals. And so this will be the last video of the week. You got to practice. I think we've got about 2 weeks, really, after this week before we do our final. So we're getting on to crunch time. So I would encourage you to start reviewing as you can. All right, so definite integrals. All right, so remember we have to do the antiderivative first. Okay, so the antiderivative of x is x squared. And then I'm going to need a half, so that when I do 2 times 2, it goes away because that's not in the answer. And then I also need the 5. So double check that. Make sure in your head that turns out to be 5x, and it is. And since it's a definite integral, I'm going to go from 0 to 2. All right, so then I put the 2 in first, so 5 halves times 2 squared, which of course is 4, minus 5 halves times 0 squared, which of course is 0. So 2 squared is 4, 4 times 5 halves, this is going to be 10, because this over here is 0, because anything times 0 is 0. Okay? All right, that was an easy one. Here's another easy one, a polynomial. The antiderivative of x plus 4. Well, antiderivative of x is x squared. And then I need a 2 on the bottom so that it cancels. And I need a 1 because I only have a coefficient of 1 there. Plus, the antiderivative of 4 is just 4x. And I'm going to do this from 1 to 4. So I plug in my 4. Remember, I plug in the 4, and then I plug in the 1. I subtract, and I plug in the 1. So 1 half times 4 squared plus 4 times 4 minus 1 half times 1 squared plus 4 times 1. Okay, be careful this minus sign in the middle. So 1 half of 4 squared is 16. Half of 16 is 8. Plus 4 times 4 is 16, minus half of 1 squared is just 1 half, plus 4. So I have 24 minus 4 1/2 gives me 19 1/2. Okay? All right, now here's one that you're supposed to have memorized. The antiderivative of 1 over x is ln of x. So you just got to need to know that. Put that on your card. I'm going to let you use a card for derivative things. And that goes from 1 to 4. So that means it's the ln of 4 minus the ln of 1. And when you do that math on your calculator, you get like a decimal, obviously. 1.39. I'm going to round it to 1.39. Remember this thing on the right over here, this is ln of 1, not the absolute value of n, but the ln of 1. Okay? All right, so now I'm going to do a trig. The inverse, or the antiderivative of cosine, is sine, because the derivative of sine is cosine. Got some extra dots there from when I did it before I made the video. So it's the sine of 3x, because whatever this argument is, this argument has to be. And then normally I would take the derivative of 3x, which would be 3. I don't have a 3 in the front, so I'm going to need a 1/3 out in front here. And I'm going to go from 0 to pi. Okay, so kind of double check that, make sure that that makes sense to you. And then I have 1/3 sine of 3 pi minus 1/3 sine of 3 times 0, or 0. Well, the other video I made, the signs, remember with our unit circle, sine is the y value. And so over here at 3 pi, the y value is 0. And over here at 0, the y value is 0. So this is going to be 0. All right, so now I do this, And the antiderivative of e to the x, well, is e to the x. So again, whatever this exponent is, this exponent has to be. And then if I were taking the derivative, if I were taking the derivative of this side, it would be e to the 3x and then times 3 because of the 3 in the top. So I need a 1/3 here because I don't have a 3 in the front. And I'm going to go from 0 to 1 because that's what that's what the interval is. All right, so it's 1/3 e to the 3 times 1 minus 1/3 e to the 3 times 0. And then I would use my calculator. I just type it in. This over here, e to the 0 is 1. E to the 0 is 1. So this would just be a minus 1/3. And this would be 1/3 e to the 3. And that's what I would type into my calculator. And I get a value of, I forget what it is, 6.36 is what my calculator says. So 6.36, in case you need to do a multiple choice matching kind of thing. Okay? All right, those are some examples of the definite integrals. So I'm going to post a worksheet and so you can practice. All right, good luck.